welcome everybody to the Elevate Your AI Training with Synthetic RGB Satellite Imagery webinar from Rendered.ai. Nice to have everybody on this call today. All right, I am Chris Andrews. I am COO and Head of Product at Rendered.ai. I've been in the geospatial industry for about 25 years, touching software like a lot of ArcGIS stuff, 3D, AEC, CAD, DIM, simulation tech, and a bunch of other things. I was excited to join Rendered about a year and a half ago, and at Rendered, I help guide the effort as well as some of the other marketing and other functions of the company. With me today is Dan. Dan, do you want to introduce yourself?
Sure, thanks, Chris. Yeah, so my name is Dan Hedges. I'm the lead solution architect at Rendered.ai. I joined back in November of 2021. And my background is mostly in geospatial, working at Esri and other geospatial firms, working with remote sensing data, LiDAR, and doing things like 3D and 2D feature extraction from remote sensing. And so I'm excited to join Rendered to bring some of that experience and to kind of push forward in the world of synthetic data.
All right, and we're definitely excited to have you, Dan. Just a quick note, anybody should be able to drop questions in the chat during the webinar, and we can respond them during the webinar. We'll also reserve a couple of minutes at the end, and we're looking forward to sharing more with you here. All right, so Rendered.ai is a 4-year-old now, just about seed-funded startup. We offer a cloud-hosted platform for synthetic data directed at computer vision content that enables customers to overcome costly challenges of acquiring and using real data. We operate on a subscription model. Our offering is a PaaS that is in the cloud with a SaaS front end. Generally, what we hear from customers is that we are the shortest path to synthetic data generation for a wide variety of applications. Our PaaS is actually backed up by our customer success team, which operates in both a studio model where we can do some work for you, but also our customer success team is also responsible for the kind of white glove subscription offering where we can help our customers get started as part of their subscription purchase. All right, so fundamentally, the issue that we're trying to help address is the fact that AI is an ever-evolving problem set. So your business problems are going to change from year to year. AI in itself is not, it's just another technology. And most companies, most organizations that we deal with aren't really worried about the AI. They're actually worried about their business problems. Their business problems are going to change. What they're looking for this year in imagery is not going to be the same thing that they're trying to detect next year. The types of things they're trying to classify are maybe they're able to do classification this year, but next year they need to improve the classification to a degree that they've been unable to do so far. So your AI is always going to change. You can't just go out and take a data set, train an AI model, and then use that model forever. Most data scientists and CV engineers are focused on data sets. They're all handling tons of data. And the vast majority of those are actually today focused on real sensor data. Data barriers typically limit the ability to train or the ability to improve training of or the ability to validate AI. Some of the limitations that we typically hear about are acquiring real data can be extremely costly and time intensive. In some cases, it might even be impossible to acquire and label accurately. Real data sets tend to have bias. Rare objects or rare combinations of objects or scenarios can be extremely hard to capture. Therefore, it can be very difficult to get enough real data to actually train an algorithm effectively. In many cases, we have customers who are doing things like planning to put new sensors in space or new sensors somewhere in the next year or 2 years. And the problem for them is they don't want to wait to start training algorithms and even marketing their solutions until they've been able to deploy that hardware. So innovation for those customers tends to be impossible unless they can have data today to test and experiment with. And then, of course, data labeling is a tremendously costly but also imprecise and incomplete human activity in most cases. But data labeling for things like IR or SAR or other types of non-visible light spectra data can actually be impossible. So the accuracy of data labeling also tends to be a major barrier when you're using real sensor data to train AI. One of the other considerations that I'd like to put out there is that it's estimated that around 85% of data is unstructured, unlabeled, and today not ready for AI. If you actually look at the proliferation of devices that's likely to happen at the edge in the next few years, where we're likely to see about 1,000 times as many devices watching us throughout our daily lives, most of the processing and information extraction that's going to be done on that edge data, which is mostly going to be unstructured sensor data, is going to be data is going to be extracted at the edge, or information will be extracted from that data at the edge using AI. And all of that AI is going to have to be trained elsewhere before being deployed out at the edge. And then it will have to be updated continuously. There's a tremendous computer vision problem in terms of there's a ton of data out there. We're going to be collecting more and more every month into the future, and yet the amount of data is vastly outpacing our ability to consume it and extract insights and information. Synthetic data has the potential to solve the AI data problem. Synthetic data is effectively engineered data that AI can interpret as real data. Synthetic data is 100% accurately labeled. It also is intentionally designed for specific training or validation scenarios. I love this quote from Forbes, which is, imagine if it were possible to produce infinite amounts of the world's most valuable resource cheaply and quickly. And they acknowledge that today you can actually do that, and that's called synthetic data. Rendered.ai is a PaaS and developer framework for synthetic computer vision data. So tomorrow's AI workflow incorporates synthetic data. We are already working with customers who are using Rendered to create data, train algorithms, test those algorithms, compare real data sets with synthetic data sets, and then based upon comparison and testing results, actually feeding information back into the creation process so that they can then generate new data sets and improve training. Synthetic data tends to be inexpensive. You can generate unlimited amounts of it on demand, and in many cases extremely quickly. It is 100% accurate for labeling. It can be highly consistent. Real data sets can be used for comparison and post-processing. And in some cases, we even work with customers who use a mix of real and synthetic data, which tends to be essential in some cases, specifically when you're trying to do things like gain small amounts of precision improvements. Data can also be designed for edge or impossible cases and for removing bias. We had one customer, for example, who took a synthetic satellite imagery data set and their generation graph, and then they decided to color all of the vehicles that they were placing in the images yellow to see what the impact would be on the algorithms they were training. And they actually got an expected outcome. That kind of experimentation simply can't be done with real data. In most cases, we do run into today customers who've already experimented a fair bit with synthetic data. In most cases, customers will come at synthetic data thinking that they can acquire some kind of simulator like an Unreal Engine even, or Unity, or maybe their own custom simulator, or something that is specific for a sensor domain. They'll either themselves or they'll contract with someone to generate a single synthetic data set, and then they'll attempt to train an AI model. And what we've found and heard from customers repeatedly is that this simply doesn't work. That one or a few data sets they generate typically aren't optimized for the AI models that they're trying to train. The real world workflow that we typically end up helping our customers implement involves someone that we typically term a synthetic data engineer working with the customer to understand the scope and requirements of the ideal data sets that the customer thinks they would apply to their training problem, then assembling a variety of components such as 3D worlds and procedural tools, simulators into what we call a synthetic data channel. That synthetic data channel then gets deployed to our managed compute and dataset management environment in the cloud, where a data scientist can then use a very simple web interface that Dan is going to show to configure jobs, execute jobs, access data sets, and even do some comparison and post-processing, all with the goal of arriving at data sets that actually work for the AI outcomes that our customers are trying to achieve. Rendered really has a solution that's composed of two parts. Fundamentally, our core product is the platform as a service that has repeatable tools and workflows for creating, configuring, kicking off, and then managing jobs and configuration around synthetic data. In that PaaS is a web interface that data scientists can use to easily configure jobs. There's also a Python SDK, and Rendered in some cases is even integrated directly into our customer's AI pipeline, where another system may be driving production of synthetic data headlessly in Rendered. Above that, we have what we call synthetic data channels that effectively extend the last mile between the platform and our customer. In some cases, we may build a channel for a customer. In other cases, customers have actually been able to build channels for themselves. And those channels typically focus on whatever computer vision domain and scenario and problem set that the customer is interested in. We don't have one channel that meets every customer's needs. We need to basically configure each individual channel to meet specific customer needs. And some customers may even have more than one channel. For example, one customer may have, an agricultural customer may have an issue where they need to identify fruit in different conditions in bins in a warehouse versus fruit that's being collected off of a machine in the field outside that warehouse. So those might be two different synthetic data channels that are in a very close, similar domain. Okay, I'm going to run quickly through a few examples, and then we'll get to the good part, which is Dan's demonstration of the Rendered.ai platform. Probably the most common example that we encounter today is the topic of the webinar, which is detection of objects in remote sensing imagery using synthetic data by training algorithms that use synthetic data coming from Rendered.ai. We have multiple enterprise and developer customers who are subscribing to us to generate imagery like this. It's a highly repeatable use case that typically ends up changing from project to project, year to year, because the things that our customers are looking for may change in configuration, or they may change in combination or pattern. In Rendered, you can basically take whatever 3D model you want, whatever scenario that you want to create, and actually implement that in a graph that can then be used to generate an unlimited amount of imagery, fully labeled imagery chips that then can be downloaded or accessed in Rendered.ai for AI training. We also have a partnership with the DIRS laboratory from RIT, and we are able to use the DIRSIG simulator, which is a highly physically accurate simulator for multiple EM domains. DIRSIG can be used to generate multispectral imaging, hyperspectral imaging, and other complex output. And DIRSIG is available for use through Rendered.ai. If you're interested, just ask us about it. And then there's a lot more development that will be coming out based upon DIRSIG. We also have our own synthetic SAR generator. And synthetic SAR, as Nathan, our CEO, tends to say, is the bleeding edge of the bleeding edge. But if you are in this space where there are multiple SAR satellites going up in the next few years, and you want to start to be able to consume and identify simple objects in SAR, our simulator gives you the opportunity to generate simple image chips of individual or multiple objects that can be used to start an AI training regimen around SAR, and we'll be improving this over time. An adjacent example to some of the remote sensing geospatial cases is we're also getting demand for ground or water-based video imagery detection, emulated imagery. In this case, this started with a customer who was looking for distant objects on the water. Eventually, we added a variety of distractors for them, such as mist and different types of waves. And that customer was so successful when they deployed algorithms trained on synthetic data that they actually terminated their subscription early. So, and then they have follow-on projects where we'll be brought to use as well. But you can do things like variably place objects at different distances from the camera, change the types of camera, even change drastically wave, weather, background. All of that in a single channel to generate as much imagery as you want. We've also done more complicated cases such as multi-sensor sensor fusion full motion video with both RGB and IR output. The imagery here is a little dated. It was an early customer project that Rendered took on, but we're seeing a lot of interest in sensor fusion going into the future. I think many customers are still trying to just process one type of imagery before they get to processing multiple at the same time. But this kind of application is intrinsically possible with Rendered.ai. Really excited to announce that we have signed a partnership with Prestigious. Prestigious is a Canadian firm that operates in multiple countries, typically serving government use cases. They launched a new product, Velocity 5D, not too long ago, that is a rapid simulation system for generating very large environments. We hope to figure out how we can use Velocity 5D directly in Rendered at some point. For the moment, what we're starting out with is we'll be offering access to 3D models for simulation that can be used in both ground and remote aerial and satellite imagery, and those objects can be used as distractors or potentially as objects of interest. If you're curious about this, just ask. Beyond Prestigious, we also are able to offer a studio team who can do things such as customize extremely large synthetic environments. As you can see from some of the images here, those environments can range from extremely highly detailed cities to remote outposts to a wide variety of ground terrain, vegetation, and other aspects that might be encountered in the real world. We can even incorporate some reality capture and conventional modeling techniques. All right, so I think we're going to switch over to Dan for a demo of our platform. So go ahead and take it away, Dan.
Cool, thanks, Chris. I will share my screen here. All right. So here I am on the Rendered.ai website. To access the platform, I can, if I don't have an account already, I can click this Get Started here, or sign in if I already do. And I'll just mention that one of our engineers, Dylan Harkness, is also on the call. So if you have any questions as I'm going along, feel free to put them in the chat, and he should be able to answer those. So here I am within the platform view, and you can see I'm a part of a couple different organizations here. And these are all different workspaces that are associated with these different organizations, and you can see that they cover a wide variety of different applications. The focus of this webinar is around synthetic satellite imagery, and specifically our RGB visible spectrum satellite channel. So I'm going to dive into this workspace here and show you what that looks like. So here within the workspace, it's sort of a way to collect all the work that you're doing around a certain project or a certain use case. And here are the graphs that are essentially configured implementations of our simulation pipeline that we've deployed to the platform. So I'm going to create a new graph here and specify the channel that we're working with. So SATRDEMO, that's our RGB satellite channel. And that is how we can get started with this new graph. And that's going to pop up the default graph here, and I can kind of walk you through what that looks like. So here we can see we've got a couple of different 3D assets. We've got a Bradley tank and an army truck, and we have control to remove these, for instance, to replace them with various other 3D objects if we have a different object of interest that we're interested in. For instance, we could be looking for crane trucks in satellite imagery, which is an object of interest that we worked with a specific customer to detect in this. So these are then being placed within the scene. So we have certain specific areas where these can be placed within our environments. And this clustering node here is going to control how those objects are placed, what sort of object density, how far apart are they going to be spaced, how many maximum types are we going to see in each image. And then those are brought into our synthetic environments. In this case, we're using 2D environments, which are essentially existing satellite imagery where we have metadata about things like time of day of collection and location and ground sample distance and other image properties, such that we can take these 3D assets and place them within the scene and simulate them within them seamlessly. So we can it looks essentially like the object was there the whole time. So we've got a variety of different parking area oriented backgrounds that we can choose from, or we can just click randomize, and that's going to choose a different area each time and randomize the environment that we're working within. Now, Chris mentioned we have a wide variety of different sensor modalities that we can support in various different channels. The sensor node here that we're working with within this channel is very simple, but we have control over things like look angle, azimuth, and ground sample distance, and the output image size. And then any of these numerical inputs can then be randomized. So we can go into our values node here and add in a random modifier here, so that if we want to change the look angle of the sensor collection between 0 and 15 degrees off nadir, we can add that in, and that will, every time this simulation runs, it will choose a different number within that range. One of the other ways to get diversity within our output data set is, we have these 3D assets, but we may want to apply some different variation to the objects of interest. So we have, it's not the same thing that we're seeing every time. So we can also apply different object modifiers here. So if we want to, change the scale or the color, or something like, add dents or rust we can do that here. So so we can add this object generator into that object modifier and then connect that all back here. Oh, add that to the wrong node there. All right, and then once we have a graph that we want to try, we can click this preview button here. That will send this off to our AWS cluster. It will take a minute or two to generate a preview image, and then once we're happy with that, we can stage this graph, and that will bring this graph over to our jobs pane. And so within here, we can open this up and provide a descriptive name for the data set and a description, and we can specify how many runs we want to kick off. So if we want just a small sample data set, we can set it to 10. If we want to train a large model and we're confident that this is the graph implementation we want to use, we can do as many as we want, 10,000, for instance. We can also specify a seed number so that the randomization is an important aspect of generation of synthetic data, but in certain cases, we will want to control for the randomization. So if we've generated a data set previously and we want to tweak some values in the graph, add in a new aspect, we can specify that seed number, and then everything about that next generated data set is going to be the same, except for those things that you've tweaked. So it allows for a lot of experimentation. So once we kick off the run, we can see how many concurrent instances we are running at. It'll give us an estimate of how long it's going to take for this job to run. And as those instances start going online, we can see that coming along. So that will run for a couple minutes, but as that happens, we can go over to our libraries page here. And this shows some of the data sets that I already have here. So we can click on a data set and see some example images. These are images of tower cranes and containers within satellite imagery. And then we can do some post-processing and different microservices to work with these data sets as well. So we can, for instance, use different analytics to observe things like mean brightness, different object properties and metrics. We can update annotations. So if by default, each data set comes with our standard annotation format, which is kind of a catch-all for all the different information that you would need about a data set. But if you have a specific need for COCO labels or Pascal or YOLO, for instance, you can run this service to convert those annotations as needed. We can also apply different GAN domain adaptation models to our output data. So if we have a target data set, we can of real data that we're looking to classify, we can train a GAN data set with the source data being the synthetic data, the target data set being the real data, and then we can deploy that to the platform and then run that GAN on any data set that we generate beyond that. So, and I've done that here in this case. I've trained a GAN to match XView data, and I've actually uploaded an example data set of the XView data set. It's an open satellite imagery data set, but you can see kind of in these examples the tone is a bit more dark and maybe a little bit more sepia toned. And so this data set is that same data set I just showed you, but with that GAN applied to it. So you can see they kind of the hue and saturation are a bit different because of that. And then one last thing we can do is we can actually, if we select multiple data sets here, we can compare them. So what this does is we can specify a fit data set. Typically, that's going to want to be your real data set that you want to fit this model to. But essentially, what we're doing is we're going to run all these data sets through a pre-trained CNN model to get various feature vectors that can be found within that. This model is trained on all the features found in COCO. So it's a wide variety of different objects, and we'll find kind of generic features found within your data set. And then what it does from there is takes those feature vectors and uses the UMAP dimension reduction capabilities to actually bring those features down to 3 dimensions, such that we can actually plot them in 3-dimensional space. And so I've done that already, and this is a kind of a pre-saved version of that. And so you can see here, these are all the images that are found within these 3 different data sets. So you can see the blue dots represent our real data. The green dots represent our non-adapted synthetic data. And then the orange dots represent the adapted synthetic data. So we can see just right off the bat that the domain adaptation that we've applied to this synthetic data set has kind of brought those cluster of points more closely in line with the real data. So that's one clear learning we can get from this immediately. What we can also see is that there are still a good amount of images that are outside of cluster in the real data set. So there are images that are unlike those that we're seeing in our synthetic data. So we can go through those and we can see, okay, what's going on in these data sets or in these images. And we can see, a lot of those are very dark. And so we can it's kind of a way to have a human in the loop to review, what is present in these images that may not be present in our synthetic data, and what features will I need to incorporate into my synthetic data generation if needed. And then because this is run through a feature pyramid network, we actually have different graphs for different feature sizes within that feature pyramid. So that's you can see here. These are those different feature sizes, and that's essentially just pulling features at different scales. So we can see at what scale are these objects more or less like our synthetic data. So this is a way to really, whereas the end goal is to have improved AP scores, this is a way to actually kind of peek behind the curtain of what an AI model would be seeing within a data set, and kind of have a human in the loop for that process. All right, so that is the entirety of my demo. Chris, I will hand it back to you, and we can take some questions after.
Okay, thanks very much, Dan. All right, just going back in to share here. All right, actually, so thanks very much for the demo, Dan. Did a great job. Some things that hopefully folks picked up on are, one, we have a really easy web interface for doing things like configuring synthetic data jobs based upon those edge node graphs. We can do things like bring in different types of 3D models, add different effects in those graphs. In the case of what this channel that Dan showed, you're actually able to generate synthetic satellite imagery, and actually there's a demo code that we'll post in the discussion that anybody is actually able to use to create an account and then enter this content code and actually get the channel that Dan was demoing. Does anybody out there have any actual questions for us? Dan, do you want to talk about any of the typical questions that you get when folks are when you're talking to customers?
Yeah, so I mean, a lot of the questions that we get are, how do we ensure that we have enough diversity in our data sets? And so, I'll just mention that, all of these channels are very customizable. So they're sort of custom applications that are deployed to the rendered platform. And in that way, we can add in a variety of different 3D models, a variety of different 2D or 3D backgrounds, and other things like, environmental aspects. And a lot of those things you can do on your own within the platform. So we have a way to upload content directly into a data volume that can then be pulled in. So all of this content is configurable, and that a lot of that can be done now with our current release of the platform to add in those various different content aspects.
Dan, did you see that Morgan asked a question for satellite images, the background scene fully synthetic or just the objects of interest within the scene?
Yeah, so that's a good question. In the case that I was showing, the backgrounds are actual satellite images. So in that case, we're just using 2D backgrounds that we're then simulating these 3D objects within. So, but the metadata that we've collected about these different 2D backgrounds, such as the ground sample distance, the blur and gamma values, the time of day and location of collection, allows us to get the shadowing right, the aspects of the image that would make it kind of seamless between the real 2D background and the 3D object. Now we can also support fully 3D backgrounds, and we've done that in a variety of different contexts. So if that can be useful if you are looking for data at really high off-nadir collections, and you need to view the obstruction of things like buildings or trees and things on your various objects of interest. But that's a great question.
And I might point out that for some sensor domains, we can't start out with real backgrounds, or it would be extremely, some of those cases like synthetic SAR or even IR, some of those things are extremely difficult to start out with only real data sets. So we're actually doing more complete environment modeling in that case, where every aspect of the environment needs to have the right resolution of physically accurate material properties. So it's, as Dan said, it definitely can be both. All right, any other questions that we have coming in? I see we've got some questions in the chat, and then there was also the Q&A, but it looks like chat is working.
Yeah.
Can we speak about the business model? So, hi, Peter, thanks for the question. The business model for our platform as a service is a flat rate subscription where we have 3 tiers. We have a developer tier for non-commercial use, which is what you actually get a free month access to when you sign up for a free account. That tier has a limited amount of compute concurrency. We then have professional tier that effectively is for, say, 1 or 2 projects running on Rendered. And that tier gets you, I believe it's 10 concurrent compute instances. I'd have to look it up. And so our model is not to charge per pixel or per image. We actually charge by month or by term, and then you generate as much imagery as you want within the compute capacity that you have at that tier. Beyond professional, we have an enterprise tier, which is more like a white glove subscription, where the customer success team that Dan is one of the leads on will actually assign a technical account manager. Will effectively end up managing a simple backlog of repeatable tasks that can be folded into a subscription. So, so those are our typical models. We have a flat rate subscription with different compute levels. And then, of course, if somebody needs to have, say, extremely complex environment modeling, or maybe something like a physically accurate, highly complicated ModTran model for use with DeerSig or something like that, we, in those cases, will often offer professional services in addition to the subscription model. Most of our customers, most of our revenue is actually generated through that subscription model today. And then, do customers go to the third-party licensing or through Rendered? We actually have all of the third-party content that we actually presented today. You can license or have access to directly through Rendered. So for DeerSig, for example, we have a concept of enhanced support credits. The enterprise subscription gets you 10 of those enhanced support credits per month. If you want to use DeerSig with your enhanced support, with your enterprise subscription, that will consume 2 of those enhanced support credits per month. So, so you actually can access the third-party content directly through Rendered. Similarly, with the Prestigious 3D model content, we have worked out a model with Prestigious where we monitor which subscriptions are using the content, and then we are the subscriber to them, just as you would be the subscriber to us. So it wraps up access to this third-party content all nicely under our standard terms of service and standard subscription. You could also bring your own third-party content or simulation, wrap it in our open source developer framework called Anna, and deploy that as a channel to the Rendered cloud, as long as it's within the terms of use of Rendered. So you could, for example, create your own synthetic indoor camera, say Roomba type robot channel if you wanted, or you could even do something much more exciting, like say implement a generative AI call that then is called out from synthetic data runs in Rendered. There are a variety of things that you could do on your own beyond just using the content that we provide. Does that make sense, Peter? Right. Okay, well, we are at 45 minutes after the hour, which is about when we were going to end the webinar. I thank everybody for participating and for the questions. And Hira, thanks for the chat message there. It's nice to see folks like Shell and Steve on the line as well. I definitely look forward to interacting with everybody again at a live event somewhere around the world. Thanks for joining us virtually today. Take care, folks.
Thank you.
Thank you, Dan.